In this example, we have a parallel circuit with three resistors where instead of knowing the voltage of the power supply, we know the total current through the circuit. So if I just label what I have, I'll call 7 ohms resistor 1, I'll call 13 ohms resistor 2, I'll call 28 ohms resistor 3, and I'm going to call the total current 0.59 amps. Now in this case, I really have no choice but to find my total resistance. I don't have enough information otherwise to do anything else with this problem, so I'm going to have to use my equation for resistance. So note the total resistance is going to be 1 over the total resistance is going to be 1 over 7 ohms plus 1 over 13 ohms plus 1 over 28 ohms. So if I evaluate this right, take 1 divided by that, I get a total resistance of 3.914 ohms. So 3.914 ohms is the total resistance. Now that's important because now that I know the total resistance, I can find my total voltage just using Ohm's law. So I know that the total voltage is equal to total current times the total resistance. Oops, R sub T. So I know V sub T is equal to 0.59 amps times 3.914 ohms. So if I multiply that together, so 0.59 times 3.914, I get 2.309 volts. And since this is a parallel circuit, I know that that voltage remains the same throughout. So I know that for every element, oops, it should be 2.309, it's going to have the same voltage. And so now what I can do is again just use Ohm's law, like what we did to find the total, and I can find each individual current since V equals I times R. So V divided by R, so 2.304 divided by each one of these. So for the first one, it's 0.329 amps. For the second one, 2.309 divided by 13 ohms is 0.178 amps. And then for the final one, 2.309 divided by 28 is 0.082 amps. And then I'm just going to double check. So 0.329 plus 0.178 plus 0.082 is 0.589. So because of rounding, it's off ever so slightly, but it's very close to the total current. So again, just like in the previous example, it's really important that you double check your values once you get them to make sure that everything falls into place.